let's walk through the 2.1 quiz morning review. Uh, the two problems are finding the derivative using the general definition of the derivative, and also finding the derivative using the alternate limits definition. So let me go through the key. So for part A, it says find the derivative of the function, not using power rule, but using the general definition of a derivative. So let's go over that step by step. Okay. So here's the limit definition of a derivative. F prime is the limit of f of x plus h minus f of x all over h as h approaches 0. So we need to make a couple of substitutions. We need to replace f of x with the original function, and then replace f of x plus h with the adapted expression. So we need to get the numerator out of function notation. So the easier one is the f of x. F of x is simply just going to be the 2x squared minus 3x plus 1. Now f of x plus h, this is where some students run into some problems. I think the tendency is students want to take the f of x and just add an h at the end, making it 2x squared minus 3x plus 1 plus h. But that's not quite what this is asking for us to do. So if this is f of x, if f of x is 2x squared minus 3x plus 1, then f of x plus h means that I'm going to replace every x in the function with a new expression, or with a new input, and that is x plus h. So that means every x in the original function gets replaced with x plus h. So now instead of 2x squared, the first term will be 2 parentheses x plus h quantity squared. Okay. Instead of 3x, now we're going to replace x with x plus h. And then there's no x here to replace, so that will stay as 1. Okay. So the argument, the new argument instead of x is now x plus h. So now we can replace f of x plus h with this full expression, which we have here. So 2 quantity x plus h squared minus 3 quantity x plus h plus 1. Okay, so that replaces the f of x plus h minus the original function. We'll put parentheses around the original f of x to ensure that we remember this negative we'll have to distribute to each of the terms. So minus f of x minus the parentheses 2x squared minus 3x plus 1. So we've replaced the numerators, got them out of function notation, and all over h. So now this is just a limit problem where if we plug in 0, we're going to get 0 over 0. So we're going to try and find a way to factor in h so we can eliminate that from the numerator and denominator and then reevaluate the limit. But first we need to expand everything out and try to combine like terms. So x plus h quantity squared, we can expand that to be x squared plus 2xh plus h squared. Distribute the 3 through, distribute the negative through to little by little we can eliminate the parentheses. And finally, the last set of parentheses, I'm going to distribute the 2 through as well. And once I've distributed 2 through, now I'm left with all these terms that are separated by plus or minus, no parentheses, nothing to expand anymore. So now we can just look for like terms. So 2x squared minus 2x squared will cancel out. 4xh will stay. There's no like terms to combine this with. 2h squared will also stay. The 3x, negative 3x and positive 3x will cancel out. 1 and negative 1 will cancel out. Minus 3h will stay. And notice that every term has an h, so we can factor the h out, cancel between numerator and denominator. So now we're just left with 4x plus 2h minus 3. Now we can reevaluate the limit. So plug in 0 in for the remaining h. 2 times 0 is 0, so 4x minus 3 is our f prime. So our derivative function is 4x minus 3. The derivative function for this original f of x is this f prime, which is 4x minus 3. So now part B, find f prime of negative 3. We have f prime of x, so now we can evaluate the derivative at negative 3. So plug negative 3 in for x, we get negative 15. So part C, find the tangent line equation. So tangent line equation, we need the slope, which is negative 15. The order pair, we have the x value. So the order pair means we need to find the y value as well. So we can plug negative 3 into the original function. So 2 negative 3 squared minus 3 times negative 3 plus 1 is 28. So we have our order pair, we have our slope, and then we can put our equation in point slope form. Okay, number 2, use the alternate or the alternative limits definition. It's going to have a similar form in the sense that it is it's going to be some variation of a slope formula, okay, since essentially the derivative is just another way to represent slope. But now we're trying to find the exact slope at a specific point for a curve, but we recognize this definition to kind of have the slope components where we have the change in y over change in x. So if we want to find the slope for a point at slope of a curve at a specific point, we can do limit as x approaches c, f of x minus f of c, all over x minus c. Okay, c is the target x value. Okay. So part A says find f prime of negative 4. So we're going to follow the definition. Limit as x approaches negative 4. So our c value is negative 4. So I'm going to step by step going to replace the c values first with negative 4. So limit as x approaches negative 4, f of x minus f of negative 4, all over x minus negative 4. Okay, so now I'm going to get these out of function notation. F of x is the original function, so that's just square root of 2 minus 3x. F of negative 4, I'm going to evaluate the original function at negative 4. So if I plug negative 4 into the original function, I get 2 minus negative 12, which is 2 plus 12, which is root 14. So f of negative 4 is root 14, all over x minus negative 4, which is x plus 4. So if we look at this limit problem, we see that we can go through the conjugate method. Now, well, first off, we plug in negative 4, we get 0 over 0. So we know we have to continue with this problem. We can work with this, remember from chapter 1, where we can one possibility of dealing with square roots in the numerator is going through a conjugate method. So we multiply the numerator and denominator by the conjugate. Okay, so the conjugate means we take the full expression here. The only thing we changed is the sign. So the negative becomes a positive, and we put these two terms over one another, which essentially is multiplying by 1. So we're not changing anything. We're just putting this limit expression into a form that is more useful to us. So we can now expand the numerator, and the square roots will cancel out. The middle terms will go away. So we're left with 2 minus 3x minus 14. The denominator, we're not going to expand. Okay, we're going to leave the denominator in factored form, and the reason why is because we want to find a way to get this x plus 4 to cancel out. This x plus 4 is causing the 0 in the denominator, so we're not going to try and expand the denominator. We're going to leave that alone. So x plus 4, and in the hopes that the numerator will come down to something that we can cancel the denominator with. So if we combine the terms in the numerator, we get 2 minus 14, which is negative 12, so negative 12 minus 3x. If we factor out a negative 3, we can we see 4 plus x is going to appear in the parentheses, which is convenient since that is what we need to cancel out in the denominator. So x plus 4 and 4 plus x will cancel out. Once we've canceled this out, so this is what's causing the indeterminate form, we can now reevaluate the limit. So plug in negative 4 into the remaining x. We get 2 minus negative 12, which is 14. So nothing to plug in the numerator, so it will stay as -3. Root 14 plus root 14 is 2 root 14. So here is our slope. Here's our limit. So the limit represents the slope at -4. So we have the slope. Okay. The next thing is finding the order pair. So at -4, if we plug -4 into the original function, we get root 14, which we've used as part of our definition. So we have our order pair, which is -4 root 14. We have our slope, which is -3 over 2 root 14. So once we have our point and our slope, we can create our tangent line equation in point slope form.